Welcome back for another video, another episode of Develop Potential, where we do electronics from concept to production. Yeah, we're continuing. And today we'll do some PCB design, hopefully. And I think we're ready. Yesterday we selected the last footprints needed, and yeah, we're ready. But today I really want to plan the layout. So I don't want to just jump straight into layout. I already did like a, first revision. But now I want to plan it a little bit. Now that we got all the components that we need to make this board happen. We got them all ready in the schematic, at least the footprints and everything. And the correct values for things, except for one teeny tiny optional component that we don't know if we should add or not. But yeah, this is where we are. Right here. We got all of these components, and we want to place them strategically so it makes sense. So I want to look into how we do that. Just plan it a little bit. I mean, this is a AC/DC switch mode power supply. So we have up to 265 AC voltage on the primary side, and then 12 volt on the secondary side. So we can't, we're gonna have an isolation barrier. I thought about, oops, okay, maybe I'll close some things I forgot to close down. Okay. So I looked a bit at the stack up, physical stack up, board editor layers. Look here then. So look a bit at the stack up. We have, sorry, a bit dry on my eyes. We have a top layer, L1. L2 we have called it P ground, primary ground, and then this is secondary ground, ground 2. Actually, I would just call it ground and then this ground 2. Or actually, primary ground on this one, and secondary ground 2 on this one. So what we will have, we'll have a top layer, a primary ground layer, secondary ground layer, and then a butt layer. Now, for the most part, I think we will place all components on the top. For the sake of just, to see how it looks like, to see it clear and clear where the components are and what they do, and maybe we'll do a little bit silk screen or some text, to or not silk screen, but some text on the top layer. Maybe even outlining what the different parts are. We don't have to do, you know, production design straight away. We can work ourselves up to it. Yeah, so I think we will go ahead and plan some layout. And I'll just as well do that in Miro. Just make a Miro board. This is how I prefer doing things, planning things. I like to have it visualized. So that's what I'm gonna do. And we can color code it a little bit so maybe not so pretty to look at. No, we're not gonna do it like that. We're gonna do it light gray. And then we'll just place in some boxes. So for instance, we have a connector that should be on one side of the board. So primary terminals, or wait, 2-pin screw terminals, terminal. Make those dark gray. Then I want to just write here primary secondary just lock that for a sec. So we have primary on this side, secondary on this side. And what else do we have? We have so rectifier, like the whole line voltage input here. We have the chip, we have feedback, we have output stage. Yeah. So screw terminal, and then we generalize it a little bit more. We do in like line voltage input. And this is hot, right? Then here, we'll just do kind of like that, transformer. And that is, you know what, I'll do like this. Transformer. And this I'll make cold. output stage, input stage. Mm-hmm. Controller circuitry. Controller circuit. I want to make it clean first, so controller circuit can be green. Or it's actually just a bit smaller, like this. Right, you have the secondary winding, and then you have the output stage, which is diode, output capacitor, right? So it's smaller than this, where here you have bridge, you have input capacitor, RCD clamp circuit, MOSFET and stuff here, right? And then the controller is quite simple in comparison to the controller circuit, so it's a bit smaller. So something like this, maybe. And then we also want, like on the entire board, we want like an isolation below the transformer. So somewhere here, I guess. And it should be, say I do like this, and then I think it's 6.4 millimeter is some standard, I guess, which I read about. So I thought maybe we can try to adhere to that. I wanted to make this go back, send backward. Oops. Right, we start with making it clean. So input stage is all this part, controller circuit, feedback circuit, or feedback. I will just write in here controller. And then maybe a tiny little, I do something like this, and then or something like that. Does that make sense? Like something like that. Coupler. So everything here, really, we isolate. So oops. Yeah. So isolation gap. Layer 1. It's still layer 1 here for now. Then we can do like this. Ba-da-na-na. L1. L2. L3. So primary ground, secondary ground 2. Okay, maybe I should just call it secondary ground. Top, bottom. Oops. I think everything should be I think also this should be isolated on the grounds as well. We have ground, primary ground for this whole stage, so good coupling there, I would say. And then the same from here to here then. Is that fine? I don't know. It's the first time I do it like that. But I think it's nice to start the design this way. And then we can, you know, outline a little bit what the different things are, not make it so complicated. And then eventually we can, you know, get it even more compact and challenge ourselves a little bit to make a better design. And I generalized it quite a bit here, but I think it still applies very well. Like, I will go into more detail planning maybe on where to put the controller chip and everything, but let's say just in the generalized area, the general area. Hey, 9T13H9, sorry. What are blocks below transformer and what is that dashed line? Yeah, the blocks below the transformer, this one, is the optocoupler. So it's isolation basically. So you have from the primary to the secondary, AC voltage, DC voltage, and then we have a feedback line that goes to this optocoupler. And this goes back to the controller circuit. So what this feedback does is monitor the output voltage. So as soon as the output voltage is, you know, based off of load scenarios or it dips in voltage or something, this feedback network will sense that and then send off signal, you could say, to the controller side. But we still have to maintain that isolation gap for it to be safe, I guess, and to protect the components and everything. So it's a closed loop. Hope that answers the question. Thank you for your comment and welcome. What is the dashed line? Yeah, this is the isolation gap. So I design a quasi-resonant flyback converter. And I'm not sure if there's a criteria on if it has to be isolation or I'm not sure. But yeah, isolation gap. Because when you have higher, I guess higher voltage, you can have arching and stuff, like the surrounding air or whatever can ionize or something, and you can actually short from one side to the other, and that's not good. As all of these components on the feedback, for example, will be rated for, you know, 50 volt or something if it's a 12 volt output, while on this side many components are rated higher, able to withstand high voltage or whatever. Yes, I will just write a rough plan, rough layout plan. So to follow that, I have it pretty much like that. But we have the screw terminal. Let's see. Just put it right in the middle. Then we have the bridge. We have this, so I'll take those a bit down. And then here is the snubber circuit. And now we need to think a little bit. Or the RCD clamp circuit. This is the MOSFET, which is connected to the IC itself. And I will put these things a little bit further down. So that's the resistor. This is the diode. And this is the capacitor. So just looking at these two, which is in parallel here. Oh, wait, I think this maybe is the resistor. It's quite a big resistor in order to dissipate all that energy. I don't know, like something like this maybe. For the clamp circuits, but that one goes up there. And what here? Nothing. Okay, maybe other way then. Actually, that doesn't matter. That's fine. What we can do is move it a bit. Maybe like this, so this would take away. A bit closer, maybe here. Wonder if it would be fine to go from here. I go this way. And then here. Like that. This now we need to place further down too, I think. Like here. the IC. Here's the MOSFET source and MOSFET ground. It's a bit annoying that it's on the other side there though. Put that a bit away first. Move it up a little bit here, so. So if this is the input stage, we start there maybe. I think I'm good with that. So E plus to this one, and then to the transformer. Nice straight line. Right? Then we have the MOSFET right here. Or wait, can I do like this? This is also now I wonder if this is alright. Check this out. Going here and then to this one, while this goes to this one and that one. Is that alright? Because then this could go, you know, oops, like that. It doesn't look that unreasonable, at least. I just put some layers, some traces there now, but obviously I probably have to make them bigger. They're only 0.25. Just put that there for now. Okay, I would just, I'll make the connections first and then we take it from there. So here, here, oops, here. give myself some room. So at least from the line voltage, we go just straight down away from the line. Maybe here I can go like this and like that. And here to ground. And here maybe back this way. Something like that. We'll just test it out, zero crossing detection. Right, we need, where's the auxiliary winding? Now that's here. So this we can have going this way. Do this one too then. Out to ground. X. Oh yeah, not connected. Ground. And then here, secondary side. Okay, so where are we now? So we have this part. We have the input stage right here. Then we have the controller circuit, MOSFET. And then the rest of the auxiliary winding stuff, like zero crossing detection, the VCC pin. Where's the optocoupler? Should be this one. Cool. So just put that here for now. Yeah, opto anode. So we turn that around. And then this feedback goes up there. Okay, let's look into those two. Those up here. They should also go to this V-in. So this is the capacitor. And this is a resistor. Ah, right, of course. we only have one part of the sensing network, which this is. So maybe we're doing it wrong here. This we can probably have pretty close. And then this. Mm-hmm. Mm-hmm. Something like that, maybe. Is this near enough? Because then we have ground here. Ideally, maybe it should be here, right? As close as possible. Then the ground pin is a bit... You know what? Can we have it like this? Can we have a nice loop there, maybe? I don't know. But we give ourselves a little bit more space than that for now. So, ground. Okay, that's that part. Then maybe on the VCC pin. And those. And those. No. What's going on here? Right, so. Those four. Next. So where's the VCC pin? Is right here. Now comes tricky one. And this, yeah, can maybe be closest or placed as close as possible as well. Maybe something like that. Although it's a bit far away from this one. should it maybe be here? Yeah, let's go for here first, and then we check if that's a good decision or not. And then this one, the electrolytic capacitor, maybe it doesn't have to be too close, but it should be, let's just say right there. And then we had this diode. What else are we missing here? This one. Something like that. I mean, it makes a little bit of sense, I think. You have the auxiliary winding, go this way and supply the chip. Yeah, let's go with that for now. I think we're actually doing, this can go out here. Need maybe a little bit more space though. Oops, and this. Okay, and then we do zero crossing. This is also from the line. Those three. Does it matter that this is before this? shouldn't really, huh? Probably matters. So maybe this should be on this side rather. Like something like that, and then it goes down. Yeah, that one is a little bit tricky. We just put it there for now, and then we check the other components that we need. So this RC filter and the diode also goes to this pin, zero crossing pin. Change. Oh. So here. Right, so we have another diode here. So this is what introduces that time delay that allows us to switch on the MOSFET at the voltage values. So this right here. And just right now I will just branch off here somewhere like so, and then up, give ourselves a little bit of room up here. Now the CS pin. Oh. And feedback. Damn. Where should that go? Now we just place it up for now and then we check later. So that's all the components on this side. Even the MOSFET, right? Yes, of course. Then the CS components, and then these three. Last one there is not. So feedback pin from the optocoupler. Right, so that's here. Does that have to be close? Probably be close to this one. And then we go need to go up there. Up there we have to go. This, where can this go? This would just need to ground. So if I move this stuff, so crossing a bit out, then this out, and I move this. So. Something like that. And then something like that. And then this goes like this. Because there's nothing else connected there. It's just these parts are the entire feedback network. So I can place that over here. This curious where I should place that between ground. So this ground and secondary ground. Maybe somewhere here. And we want isolation between the entire board right here too. So we line that up perfectly. Ah. Okay. It's taking shape at least, so okay, so here we have the cathode, here's the anode. So this is what we have right now. Something like this. Input stage, controller circuit. These we haven't fixed yet, but we will. And if we look at our rough layout plan, we have an input stage, controller, optocoupler, transformer, output stage, feedback, two terminals, isolation gap. then primary ground, secondary ground, 4-layer board. Sounds about right. Let's do this real quick. So this is the output diode. This package is also a little bit strange, right? This, but it's the one I found. So anode and then P out. The load here, it's crazy, crazy load. So I'm just thinking orientation on this one. Can it somehow be? Of course it can't. It has to be like this, right? Has to be. And then we have the output screw terminal. So we just connect everything now. And then of course we'll make it nicer and everything. Okay, cathode. Wait, I will go about it like this. Those two system V out. Is there a quick way to just of course. So like this and be perfect. That's what I wanted. So we have this, I'm guessing the first. Does it say what? No, but it should be. Okay. Why is the 18? Smaller package than all the other ones. It's a bit strange, maybe. This is 0603. This is 1206. This is 0805. What? Oh, I mean, I did size them. So it was very little current here, a little bit more here. And a little bit more here too. That's why I did it, I guess. Yeah, we can change that though. Now I'm curious, how close do we have to be how close should everything be here. Like for example, taking the output here, let's say. So we take this one first, goes to, this is the divider. No, wait. That one. And those two. So, like that. The routing starting point violates DRC. Okay. So like this, and then this ground, this out to ground. And then this up to the cathode there. Okay, wait a minute. Let's do rough placement first. So I'll take this a bit further down. This one here. This. Here. This also here. Thank you for that like. Appreciate it. Appreciate it. You know, we need to do it like this, I think. Give ourselves a little bit more space again. So we group it by a function, basically. Start there, and then we'll go over it later. And I have a habit of maybe following the schematic a little bit too much, but at least I start this way, and then we can make it better. Could even have it like this almost. So this D2 unknown. Whoops. Secondary D. So. And then let's add a rule area, a keep out. So for instance here, area name, ISO, gap, maybe. Keep out tracks, keep out vias, keep out paths, keep out footprints, keep out copper fill. And this should apply to all layers then. Outline hatch pitch. Hatched fully hatched. Right. ISO gap. Wait. How do I reset again? Oh yeah, here. Damn it. So here, from here, we do keep Control Shift K. So from here, Control Shift K. Okay. ISO gap. So that's, so right here, that's 8.25 millimeter. And the requirement is 6.4. So here is even enough. Let's do 7 then, 7 centimeter, 7 millimeter, I mean. Then we go down all the way to here, let's say. And then we go back. And then up, whoops. There. Awesome, that's good. ISO gap on all layers. And now I can't place the tracks there. So it won't let me because I defined that keep out. And this is on all layers. I was just thinking a little bit on orientation when it comes to this, in terms of wave soldering and stuff, because you want to have the same through-hole components, you know, in the same direction as on the conveyor belt. So this should ideally be perpendicular to itself here, I guess, ideally. I don't know. That's what I think. But it can't really be another way, can it? Here. Let's see if we can put down a ground layer. I guess we did that at some point too. Why can't I move it? Yeah, here you also see that the keep out area is also, or the isolation gap is also on the second layer, just as we planned it on in the rough layout plan. Oops. It's not entirely straight, is it? No, it's straight. Should be. So this is, yeah, just ground. Right, just ground. And then we leave the second side, or the secondary side, we leave that open, and then we can, here we also see the, on that layer, it's also a keep out. And S, no, ground 2. Go, okay. Da-da-da, da-da-da-da-da. Da-da. Not sure how much space it needs here. Like that. Also check this layer. But we got nothing. But at least we have still the same gap. Cool. Oops. And then vias for ground. Oh. Oh, no. Now I wanna reckon 0.8, 0.4. Oops. Oh, they're not freaking. No net. Right, let's take them away again then. So, and then no. Wait, how do I edit it? How to edit via plus routing or free VCAD. Oops, wrong. Or maybe better to just do. This part is a bit annoying. That the cathode is on this side. It doesn't hurt to move this away though. Of course, I guess. Move it a little bit over so I can get a trace going there. Like so, maybe? Oh wait. It's not really pretty. Oh shit. No. Broke part of my keyboard. I broke the shift. Maybe I can glue it on the tiny thing. Damn, I've been assigning for 1 hour 30 minutes non-stop. We're close to being done. So I will write this one. And then this one. Yeah, and then it's this part that I didn't fix. I can go through here. Honestly, I think that's the only way to do it. So we have the components here, and then we hook up. Oh wait, what am I doing? What am I doing? So here, here. Hold on. I'm thinking here. That's the only part we don't have now. It's this. And then we have the whole freaking thing. I completely forgot that I made myself a tea. Completely forgot it. Guess I'm drinking cold tea. Oh. Thank you for watching. Made some real progress today. It really helped to make a rough plan too, even though it's not that complicated. Obviously, it's two screw terminals, a input stage, a controller area, output stage, feedback, or transformer, output stage, and then the feedback loop, optocoupler, and Y-rated capacitor, safety capacitor. But yes, this is what we're doing here at Delta Potential. We're doing a little bit as we go and learning and designing, and we try not to let anything stop us. And obviously here the traces, we can definitely maybe do some copper bore for this B+, for instance. Maybe that would be nice. From this area all the way over. Or at least wider traces. Yeah, and I look a bit over what is required. It's not really that high current on any of this. On this part, yes. So on the drain here, so I can select here also because of the line voltage here, obviously. But all this other stuff is not really that much. No, we did necessary calculations, I think, to determine that. So we'll look over and then we check how much current is here and etc. And then we set the necessary trace widths. Okay, but first we need to fix this whole thing. And I mean, looking at the schematic, this is after this capacitor. So for example, if we would place it here, I think that would be all right. Then we move ourselves in this direction. Would be good if we even had it up here, I think. We're only sensing this part here anyways. We could put it here. Something like that. Maybe this part we move a bit over, like that. And then we take this out and here. And it, no. Something like that, maybe. It's not that, that is not that bad, I think. So, right. That's the entire board right there. Can I move the whole thing? Move. Place it right in the middle here, so. It's the the vias are wrong. So screen clip by Solder Mask. Ah, right. We haven't we haven't looked at the cell screen at all actually. So yeah. But that we will get to. So let's have a quick look. I mean, it doesn't look that bad. Wait, how do I put a board outline here? Okay, edge cuts. Oops. I need to take a quick break. Laundry is done. Yep. And I can hear it beeping. I'll be right back. Sorry about that. Just gonna fix this up too, but first just do like that, and then tools or fill zones. So, and I'll fill zones again. What's the problem here? We still have a bunch of errors and some warnings, and most has to do with the annular ring width of the VS, it looks like, and then some items not allowed in the keep out area. Footprint, this whole footprint is not allowed now, so we need to allow footprints. But anyways, this is how it looks like. And maybe we do move this connector down here so it's cleaner. Or looks nicer maybe. Right. Yes. But I've been streaming for almost 2 hours. Really appreciate the audience today. We got a lot of views, actually, 22, which is awesome. I really appreciate having you here. Thank you for watching. Really appreciate the support, and I hope you learned something and had fun with it. And this is what we do here. We will design, we will do the necessary work beforehand to understand what we're designing, and in this example project we did that, and where we're doing that, all components we have selected, we have carefully selected. We've probably taken some shortcuts and done it in a rough way, but still very valid, I think. And of course we will revisit all component selections in future episodes, doing more design, more revisions, etc. We need to clean up the annotations here so it looks nicer. Put in a bit explanations, you know, maybe something for the keep out area, or, you know, various stages of this PCB board. Anyways, thank you so much for watching. And until next time, ciao.